And normally the system would boot right up, but I'm going to kind of start it up so you can see what's going on. So, so there's a big DC connected to the battery that's normally on, so I'm going to turn that on. So that'll now energize the inverter. And
does it have a knock switch?
it doesn't have a knock switch. They're not as clever as the Germans. So,
Knock knock.
so let's see. So the inverter's on. I haven't turned the AC power on, so I'm going to turn the power on. And what I'm doing is I'm now turning the output of this inverter to the load panel here. And as you can see right now, the grid tie inverter is like flashing a failure signal.
What's powering that light?
The array.
Oh, okay.
Yeah. So these things actually run on DC power. They're brains. So they, when the sun goes down at night, they go to sleep. They're dead. You can't even knock on them and get them to wake up. You know? They're just sitting there doing nothing. So
Just need a bigger hammer.
Full mood, maybe.
The alarm clock.
Yeah, so, but yeah, the morning sun comes up, they wake up, and then they start doing their business. So you'll see right now it's doing nothing, it's saying, hey, the grid has failed, but that'll change here. Okay, so voila, but you got power.
Let there be light.
Let there be light. So, so now we're running off this battery pack. We're not running off the sunshine because this thing hasn't connected yet. It's still like, hey, we got a problem. But now it's, you can see the light changed. It's going to seeing disturbance. It'll go through recognizing that, hey, we got stable power again. And then it goes through a 5-minute wait period, and then it'll start pushing power into the system here.
So it synchronizes to that inverter?
Yeah, so it synchronizes the AC output here, and it has no clue that it's not grid. It just sees 240 volts, clean. It's got to be within certain, tolerances of frequency and voltage, and other than that, it's going to take care of things. So I'll just describe what's going on here. This is just the control panel for the setup here, and it tells me all the key parameters I need to pay attention to. So right now it's saying the load is 180 watts. So the house building's pulling 180 watts right now. I can turn on this electric heater here, and that goes up to 780 watts. So you can see the amount of power you're drawing and whatnot. Let's shut that off here. It shows me my battery voltage. Right now it's 49.1 volts. And it's got a little general battery state of charge meter, so you can kind of see what's going on. So this would live in a convenient place, inside the house or in the garage. So when you're off grid, you can kind of see what's going on, which is important because you sort of captain of your ship at this point. You're on your own island. You've got a certain amount of energy. Now you got to work with it. So if you want to be just like, hey, I don't want any issues. I want to rock and roll just like I was.
So you
you're
don't
going to need a
turn
really
on
big battery bank, or you need a generator. But if you're willing to be, hey, maybe we'll cook the roast the turkey another day.
So you don't want to turn on the dryer and the oven and the air conditioner all
There
at
you
the
go.
same time.
Charge the car.
And charge the
Yeah.
car, right?
Yeah. So that's what I thought might be interesting to y'all, because you're electrical vehicle enthusiasts and owners and so forth. So, and most of you don't even have a solar system. But here's a way that, hey, I can charge my car when the grid goes down, everything, people
It's
are.
neat because you're not getting power at night. If you're charging at night, you're always going to be charging from the grid or from the back.
Yeah, well, I'd say, so here's what you'd want to do in that case. I'd say, no, you want to preserve your battery for running your house at night. When the sun comes up, then you plug in your car.
Yeah.
So, because like I said, most of these systems produce more energy during the day than the house can use during the day, right? Because they're, on average.
That's assuming your car is at home.
That you're not at work.
Oh, yeah, well,
Yeah.
tell your employer to get one of these things too.
Well, I'm retired, so it wouldn't be an issue for me. but-
Yeah, or you can just strap one of these things on the back of your car and.
Yeah,
Trailer.
Put it on a
Yeah, wheels on
Just
tow it.
pull it down the street, right?
George will do that.
Actually, a little trick I can do here because, and it's just a minor thing. This is actually a 208 volt building. There's a 240 volt inverter, so that's why this thing isn't accepting it. So I got to actually got to shut this thing down completely, and then it'll wake up and it'll reconfigure itself to 240 volts. So that's why I didn't actually pick up here. So by killing that, I'm gonna shut the brain down,
Yeah, I had
disconnect it from the array.
tweak on my.
I'll put it back and then it'll come up.
What do you do with the excess electricity once the batteries are full?
Yeah, so, good question. So, you'd want to use it. So if you're truly in an off-grid situation and you're like, hey, the battery's full and the sun's cranking and we're not using it all, I'd say do the vacuuming, run the wash, just start using that power, because if you don't, this inverter, and I didn't get to that point, and I'll show you that here, this will actually, so the way it tells this thing to shut off is it'll actually change the frequency, so it's running exactly at 60 cycle. It'll actually start slowing up to 61.5, and it'll go outside the acceptable realm of this thing, and it'll just shut off as if the grid got bad. This thing will bring its frequency back in, this thing will reconnect, and it's just sort of this back and forth kind of
So
thing.
much for your electric clocks.
Yeah, and actually this thing's smart because it'll actually slew the frequency one way, then the next time it'll slew it the other way, so it'll actually, yeah, so they thought about that, so.
What happens then is that the batteries get fully charged and it effectively shuts off the solar charging.
Correct, right. So better than that, I mean, you could get clever and start hooking up some, well, whatever, you just turn on loads. Because you might as well use that
Space
energy because
heaters,
it's wasting
air
energy.
conditioning.
Space heaters, charge your car, use it. So that's really what you want to do. Sir?
If you pull the bottom electrode out of your hot water tank, connect it in, when you have an excess, you can heat your water.
Absolutely.
And leave your upper electrode in it.
Absolutely. And these inverters have outputs where you can control relays and so forth. So you could put a contactor into a circuit, and when the battery gets to a certain point, you can turn on anything you want. So you can kind of automate that too, if you wanted to. So, yeah. Which is actually, for off-grid people, this is an important consideration because, this is their normal state of being. So, you have all the solar power, middle of the day, what do you do with it all? Your battery bank is only so large, so you really want to utilize it while it's happening. So,
So that's when you
off-grid, you
pump
wanna
the
be-
well water into the
Keep the
overhead
swimming
tank.
people keep asking about that. I'm like, yeah, this sounds kind of good, but I think the cost and everything else doesn't warrant it. I think we'd be better off just buying more batteries, frankly.
Well, if you've already got one of those water.
Yeah, right. Then you have to
tanks.
buy it. You have to put in high.
Some of the space-launched solar power photovoltaic systems had 30-to-1 concentrators focused on the panels, and then they had serious cooling on the back of them.
Yeah. Well, I know a lot of people ask about concentration, and
That's right, space is
it's
not.
coming around, I think. But I personally,
Convection cooling.
You
doesn't
know,
work in space.
one of the virtues I mentioned, these panels, I mean, they just run and run. In fact, this one back here, so by the way, I meant to point that out. So I grabbed that in 1992, and it's actually been in the field most of its life. It's a Siemens, it's a 55-watt panel. So believe it or not, that was a utility-sized panel in the early 90s, 55 watts. And that thing still puts out the same power it did as when I first got it. So, I mean, this technology is essentially inert. We all talked about degradation. But even at 0.5, if you compound that over 20 years, you're only down 10% kind of a thing. So, but anyway, these panels are just ridiculously robust. And my thinking is, you start putting 500 Fahrenheit temperature gradients on anything, and I think you're just going to end up with a different reliability. So I know they're all moving towards like, oh, let's just have a few silicon cells, but the silicon cells have gotten less expensive. So I don't know. Concentration probably has its place. I haven't really seen it commercially viable, and then I would always question survivability. And the people are asking about shingles and other things, and I'll just say this: I mean, there's bound to be great new technologies, but can't say enough things about just the conventional, good old solar panel. These things just work and work and work and work. So,
Can you walk on that
reliability is a
panel?
big deal. You can. You're not supposed to, but our guys do all the time because they're up there in fields of panels, and they walk on the frames, of course, as much as they can, but you can.
Does that mean it's running?
It means it's qualifying the AC power, and it should come on.
Been doing it for quite
so-
a while.
Yeah, it's been more than 5 minutes, so maybe it still thinks it's in 208 mode. But I had the thing off for a while, so I'll give a little bit of time here to see what it's doing.
I've seen
here.
one of our former installers who probably weighed upwards of 200 pounds. He slipped on a
Oh,
frame and fell directly in the middle of the module, and it bent, rebounded, and it's fine. $200-pound guy,
Wow.
slipped and fell in the middle of it. This time.
Well, they do make two different kinds of faces, the poly face and the glass face.
Right.
One will accept hail with no problem, and the other is kind of an
The
ouch.
backside's pretty sensitive, yeah, absolutely.
What have you seen for, over the past, I don't know, 10 years, cost per kilowatt?
Dramatic reduction.
I mean,
Yeah, like,
10 years ago, it used to be like $8 a watt to install, and you can go as low as $3.50 a watt now.
radical reduction, so,
What do you
which,
see for
which
10
speaks
years
to,
in the
you
future?
know, the,
Yeah, and then,
sorry,
What do you see for 10 years into the future?
10 years in the future. My personal opinion is these panels are pretty damn cheap at this point.
Yeah, but-
You know, they're made of aluminum, glass, silicon, copper, silver, I mean, all these things that aren't necessarily going down in price over time. The big challenge was silicon, because just in 2004, imagine this, so 2004 was the year that solar eclipsed the electronic industry in consumption of silicon, because these very cells are the same substrate that all microchips are made in, microprocessors, diodes, and you name it. That's where they start. And they were just piggybacking on the extra that was available from the electronic industry. And that was 2004. So 2004 prices were actually going up in PV because demand started picking up. Here we go. Here's some clicking. Clicking's a good sign, I think. Yeah. There we go. It's solid. So now we are. So now you can listen to the tune of this. So now we're at minus 1,400 watts going to my battery bank. I better turn on some loads. Okay, now you hear it just shut off?
Yeah.
So the battery went up, this thing got up to its max battery voltage, said, hey, it changed the frequency, kicked that thing out. But now what I'll do is I'll turn on a 900 watt load, and it'll be a different story. So now that energy will actually get used, right, because now I'm burning it.
Turn on the coffee maker over there too.
Yeah, maker, yeah. So where are we, 10 years in the future, I think you said? Oh yeah, so then enter the Chinese. And the whole industry just changed. I mean, they started building silicon foundries. So the limitation was the silicon. First of all, silicon is the second most abundant element in the Earth's crust, right? But in its raw form, it's perfectly useless. I mean, glass has silicon dioxide and so forth. So you got to go through all these energy-intensive processes to get it to become a wafer, which is actually an important consideration because the question is like, hey, are we fooling ourselves here? If we're dumping all this energy into making panels, are we really net benefiting? So the answer to that is somewhere between 2 to 4 years of production out of your solar array will produce all the energy that went into making that system, including us driving around in trucks and putting rails in and all bits. So it's a net energy gain. If it wasn't, this would be an absurd, activity. But anyway, the silicon. So the Chinese got in and they started building silicon foundries, which are multi-billion-dollar investments, and they just went huge. And the prices just from that point started plummeting. And so as of 2007, 2008, prices have been steadily coming down, but they plateaued. And the question is, are they below really where they should be due to like oversupply? Because actually that's what happened is we got into an oversupply situation. And
Right now,
DC under voltage. So actually, I pulled too much of a load before.
Before the solar
the
kicked
array,
back
these
in.
batteries are already down, so
Tony, I'll just speak to that really quickly about the cost. Right now, it's the soft costs that are keeping PV high, permitting, and the installation and the labor costs. But the fixed costs like the production, the manufacturing of the material is very, very low.
It probably won't go much.
Probably won't go down anymore.
What about the soft costs coming down?
I mean, that's going to require sort of a uniform acceptance of permitting requirements and things like that, and a more uniform incentive